Hey, hello statistics. Last series of videos, hopefully three short ones. Our last chapter of the year, chapter 9, which is about regression. I don't think that anyone can teach a stats class without talking about regression analysis. People who go on and become an actuarial scientist, an actuary they work in an insurance company. Or someone who becomes a statistician. These people work in all kinds of places. Every business has one. It's a booming field. Insurance is a billion-dollar industry, not just in this country but worldwide. It doesn't matter what kind of insurance: car insurance, health insurance, life insurance, insurance of insurance companies. I had a professor in college at Mansfield. He was a fairly new professor. He spent 12 years working in New York City as a pre-actuary. He worked as an actuarial scientist for an insurance company that insured other insurance companies. The guy made crazy amounts of money. He lived in Manhattan, and he decided after 10 years that there was no way he was going to be able to do that for 20 more years. Him and his wife wanted to settle down, and then he ended up at Mansfield, raised a family, and I believe he's probably retired by now. So I know he retired early because he made crazy money when he was younger. So anyway, what is regression analysis? Well, you already know a lot about regression analysis. It's just that when you took it in the younger grades, particularly Algebra 1, when you took the Keystone Algebra 1 test, we didn't call it regression analysis. We called it the line of best fit. So here's what we have. If you take a scatter plot and we put some dots on here, we put some points on here, that's called a scatter plot. And your Inspire will do this. And I'm not going to go through the steps here on the video, how to do all this on the Inspire, because I can't show you the Inspire screen very well. If I was making this video in my classroom where I could put the Inspire screen via computer up on the big screen, then we'd be okay. If I was making the video with my computer and I could hook up the camera to the computer, we could do it. But I don't. I'm out in my workshop. I just have a camera. So we can do this. What will happen is the instructions for all this stuff I have typed out, and I will post them as a document. So that way you can look at them. And once you go through it one time, maybe twice, you're going to be okay. It's really pretty easy. Furthermore, if you Google or do a YouTube search and you type in Inspire, N-S-P-I-R-E, if you type in Inspire finding regression line, you're going to have tons of videos to choose from, tons of material. Just make sure it's the Inspire. If you fell in love with AP Stats Guy and you want to watch him, unfortunately he made his videos before the Inspires, so he's using the old TI-83s. And you're going to get instructions that don't make any sense to your Inspire because he's going to talk about keystrokes that just don't exist. So anyway, here's a scatter plot. What is a regression line? We call it now a regression line. You learned it in algebra as the line of best fit. Okay, the line of best fit. Why the word regression? Well, regression means we're going to regress. Regress means we go backwards. So what we're doing here is we're going to take all these dots, which are ordered pairs. Okay? Maybe down here is like, maybe down here is I don't know, a person's height on the x-axis. And maybe the y-axis is like, their IQ score or something. I don't know. I'm just making stuff up. So we plot that, and you want to try to say, well, does one thing imply another? Is there a relationship between these two things? So to zero it home for you, all of you are at the driving age. One of the big discounts. I'm going to give you a little hint and tell your parents this too. When my daughter and my son has his permit, my daughter already has her driver's license, and they go to Northeast, and Northeast doesn't have driver's ed. They just don't have it. So I inquired with our insurance company. We have Progressive. How much of a discount do we get if they go through a driver ed program? My agent told me the amount. Next question was, are your kids good students? And I said, well, yeah. And she said, well, you can get a bigger discount on your vehicle insurance. The good student discount is greater than the driver safety class discount. So all we had to do was provide a photocopy of a report card. So we got a bigger discount. And then the kids didn't have to drive to Towanda and pay, or drive to Athens, and we didn't have to pay somebody for them to go through the driver ed training and the behind the wheel stuff. So how do they figure out that the good students have less accidents? Why do they give a discount for that? Because they figured out that relationship. You know, they figured out, like, okay, let's change this. Let's go grades, and let's make, number of accidents. Now, obviously here it's the wrong way, but you get the idea. I'm not going to leave that there. We'll go with height and IQ. Okay? So when you were in Algebra 1, whoever you had for that class, probably Mrs. Trowbridge, maybe you had MP or Mrs. Strunk, because I know you didn't have me, because it's been probably 8 years since I taught Algebra 1. So you were taught to, let's just put a line through here like this. And you were probably taught, well, put an equal number of dots above and below. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then that one was like almost right on the line, so we'll call it good. That was kind of the way we had you estimate this line of best fit. Well, in statistics, we have a much better way. How your calculator figures out that regression line is going to be revealed to you in part 3 of this video series. But for right now, we want to focus on correlation. Okay? So this regression line puts it there. Now, why calculate? Why find a line of regression? Why do we want to do this? We do this because it creates a mathematical model. And a mathematical model, when you hear the word model, you probably think of like, well, I put a model train set under my Christmas tree at Christmas time. It's like a little miniature village. That's not really the kind of model that a mathematical model is. A mathematical model is nothing more than an equation, a formula, or a series of equations or a series of formulas that represent a situation. Okay? So why do we find a line of regression? To make predictions. To make predictions. And the regression that we're going to use is always going to be linear. So what does linear mean? Linear means it's going to be the equation of a line. What's the equation of a line look like? Y equals mx plus b. Is there other types of regression? Yes. Instead of linear, you could do quadratic regression. So now you're going to be looking at a U-shape, finding the equation of a parabola. You can do absolute value regression, where it would be a V. You can do, for those of you that know trig, you can do sinusoidal, which is the wave. You can do cubic, y equals x cubed. You can do all kinds of them. And we're only going to do linear. Okay? If we were in class and everything was back to normal, we would probably spend one day exploring some of the other buttons on our calculator to see some of those other things. But for right now, we're only going to do linear. So what the calculator is going to do is it's going to find this regression line, and we're going to use that to make a prediction that happens out there. So let's talk about correlation now really quick. Correlation. Now that's a word that mathematicians and statisticians have quantified over the years. And when I say that we've quantified it, it's one thing to say, well, there's a correlation between between your height and your IQ. I'm just making that up. How do we quantify that? Well, when you quantify it, means you assign a number to it. And if there's a number attached to it, mathematicians can then say, well, this number is better than that number. This correlation is stronger than that correlation. So let's look at a few scatter plots. Here's a scatter plot. Here's 4 basic scatter plots. And they're kind of grouped together. So if you kind of look, I'm going to draw a line like this. I'm going to add another 1 or 2 there, so I'm leaving space to expand here in a second. Correlation. Correlation. If I were to draw the line of best fit through here, if I were to draw the line of best fit through there, it would be positive. We would say this has a positive correlation. If I drew the line of best fit, it would still be positive. Now, I hope you're looking at that and you're saying, Mr. Lascan, that looks like lines that have a positive slope. You're correct. If I look over here, these two have negative correlations. Why? Because if I sketch that line of best fit, that's a negative slope and a negative slope here. So positive and negative refers to the slope of the line. It also refers to the direction that the scatter plot, that the correlation is going. But how come there's 2 different ones here? This one up top, we would say this is strong. This is a strong positive correlation. Down here, because the dots are more loosely packed, we would call this a weak positive. This would be a strong positive. Over here, this would be a strong negative. And this would be a weak negative. So what does strong and weak have to do with the correlation? How tightly packed the data points are around that line of regression. If they're packed really, really tight up here, we would say they're strong. Can you add other adjectives? Can you say very weak, very strong? Yeah, you can. In fact, in the next video, we're going to learn how to determine if there is a correlation at all. Because a lot of people use this and they get themselves into trouble. We'll talk about that here in a second. The last thing is, what about no correlation? No correlation. Well, no correlation looks a lot different. You know, you could put, if you had those dots, how would you draw the line of best fit? Would you draw it like this? Would you draw it like this? Would you draw it across? Would you draw it vertical? I don't know. I don't know. So that's one way we can have no correlation. Now, since we're talking about linear regression, technically we want to put the word no linear correlation, because what if we did this? Ah! Algebra 2 rears its ugly head, and boy, it's ugly, isn't it? Because I don't know of anybody who ever said, Algebra 2 is my favorite class. Everybody hates Algebra 2. I'm not sure why. Look at that. What is that? It's a parabola. That's quadratic. What's the equation of a quadratic? Y equals ax squared plus bx plus c. In standard form, see, I know, some of you, you're already getting a headache. Standard form, and then there was, what's the other? There's the factored form, there's the vertex form, oh my gosh, all that good stuff. But how would you draw a linear regression here? Well, on this side, it goes down. It's negative, it's strong negative. What about over there? Well, it's strong positive. What about the bottom? It's kind of, ugh. Guess what? That's not a linear correlation. What is that? That's a quadratic correlation. So, since it's perfect quadratic, it would be no linear correlation. Okay? So, since we can quantify this, okay, there's your scatter plots. Pretty easy so far. Pretty easy so far. There's a super duper long formula on how to find what we call the correlation coefficient. I think that's the way it's spelled. Coefficient. The correlation coefficient. What's coefficient mean? We gave it a number. Because it's one thing to someone, like maybe you're sitting there in class and you say, hey, my graph has a strong negative correlation. And maybe the person sitting next to you says, yeah, well, mine's strong negative too. Well, whose is stronger? It's tough to tell sometimes if you're just looking at a graph. That's why mathematicians have chose to quantify this. So the correlation coefficient, because there's two R's, mathematicians have chosen the small lowercase r to represent the correlation. So correlation is represented by the letter R. And R varies from -1 to 1. -1 to 1. If you have a 1, positive 1, that means your scatter plot is perfect. That means your dots make a perfect positive line. If you have a -1, it's a perfect negative dotted line. If you're in the middle at 0, well, 0 is probably one of these things. Like, we don't have any correlation. The closer it is to 0, the less correlation there is. So if you got a correlation of 0, you could say, well, there is no linear correlation. There isn't one. So the closer you are to 1, so up in here, so up in this area here, -1, you know, if we kind of say, okay, there's -0.5, here's positive 0.5. So probably from 0.5 to 1, we're going to call that strong positive. From -0.5 to -1, we're going to call that strong negative. What about this region in here? Well, it's going to be, you know, it's going to be weak. It's going to be weak, and then smack dab in the middle, you're going to have none. But again, because mathematicians are numbers people, we want to assign it a value. So there's this super duper long formula, which I'm not even going to show you. It's in the book. If you don't want to look up, and if you don't have your book, Google it. Google equation for linear correlation coefficient, and you'll see it's crazy big. It's something we don't want to do. Our calculator will do it for us. Okay? So in order to do it, we have to find the linear regression line. Okay? So the big thing about correlation, is correlation does not imply causality. Now, some of you with really good memories, because in my stats classes we have lots of highly intelligent young people. Chapter 1, way back in chapter 1, we were just getting to know each other. It was September. It was crazy hot, and I remember it was hot. It was humid. We haven't gotten to those days yet here this spring, but we did a lesson in chapter 1. It was a few-day lesson about like all the ways that statistics is misleading. Remember, there was like bad graphs, and there was all this other stuff, and it was in chapter 1. And one of the biggest things there was correlation does not imply causality. What does that mean? That means just because we throw a graph together. Let's do this. So let's just say, I don't know, we'll come up with something. Let's here's a scatter plot. Okay, the x-axis. This is the independent axis, right? Independent. And this is the y-axis, the dependent. See how algebra 1 comes back? The dependent number depends on the independent. So let's suppose, let's see, I don't know, let's suppose down here this is like the number of shoes that you own. And let's say over here, this is your height. Well, if you look at that scatter plot, you would say, well, that's a fairly strong correlation. It's a negative correlation. So you know what that means? That means the more shoes you own, the shorter you are. Because height, getting taller, getting shorter. So the more shoes you own, the shorter you are. Is that true? I don't think so. This is where people get in trouble. They see a correlation. Maybe somebody calculated this on their Inspire. They plugged the data in, and guess what? Your R value, it's got to be negative. So maybe your R value is like negative 0.8. And you say, well, geez, negative 0.8, that's a fairly strong negative correlation. Does that imply causality? What's the causality? The more shoes you own, the shorter you are? Those two things, okay, sure. We graph them on a coordinate axis. We found, but does that really mean that there is something between the number of shoes you own and your height? No. Okay? So this is where people get in trouble. Okay? So, you know, a lot of times, especially, listen, you know, I know young people like yourselves probably don't use Facebook a whole lot. You guys are more into, you know, Instagram and Snapchat and TikTok and those things. But, you know, when I read stuff on Facebook, you know, there's always people spewing falsehoods and these misleading statistics. And, you know, if you read an article, first thing you want to look for, when was it written? Because if it was written in 1994, it may not apply now. Okay? So you got to become a little savvy about things. And this is one of the things you need to be savvy about. Correlation does not imply causality. Okay? So the R value. One more time. I just want to write it down up here one more time, because then I will post a document that will take you through how to find it. So here's +1, here's 0, here's -1. This is your R value. What's R? Correlation coefficient. Okay? If it's 0, we're going to say there's no linear correlation. Up here, this is very strong. Okay, when you get here, there's 0.5. So there's like 0.5. So from 0.5 to 1, you're probably looking moderately strong. then you're getting closer to 0, you're getting weak. And then you always have this area in here, you're like, Same thing here. Negative 0.5, this is really strong down here. This is moderately strong. Here you have weak. But what in here, so like if I said to you, hey, put this data in your calculator, tell me what the correlation is. Use this as your x-axis, use that as your y-axis. Tell me what the correlation is. If someone types that in, they're like, it's 0.6, Mr. Scan, it's 0.61, 0.61, positive 0.61. Okay, tell me about the correlation. 0.61? Well, that's really close to 0.5. Would you call that? Sure, it's a positive correlation. All positive correlation tells you, all positive is that this line of best fit is somehow going up. Is it strong or is it weak? Well, what does strong and weak tell us? Remember, strong tells us that these things are packed tight, and weak tells us they're packed really loose. So 0.6 is one of those iffies. Okay? So when you're looking at in the middle there, and I'm going to hit that in the next video lesson, because now we can use a hypothesis test to actually determine if there's linear correlation. There's a test for it that tests how good this R is. It's really easy. The calculator does it all. And just like in our previous test, if the P is low, we're going to reject the null. If the P is high, we're going to let it fly. So this is just an introduction to linear regression, correlation, expanding on some Algebra 1 concepts, and we're going to tie it in with statistics. So part 2 of this lesson, which I'm going to tape just next, but you'll probably watch a few days apart. Part 2 is how to test a hypothesis to see if there is actually linear correlation. And then part 3 is going to be about a residual value and plugging numbers in. All of this stuff uses the calculator extensively. So until the next video, take care and we'll see you soon.